Today we're going to be talking about polygons, and polygons are created by a number of sides, and we can name those polygons by the number of sides that are used to create those shapes. We've talked about a few of these types of polygons before, so I'm just going to name them yet again. For the number of sides for 3, that type of figure is a triangle, and we've talked a lot about triangles before, a lot of different properties. Remember, for a polygon, if we have a 3-sided figure, it will be a triangle. For a 4-sided figure, that's going to be called a quadrilateral. And we're going to be learning about more types of quadrilaterals later on in this chapter. For 5, it's called a pentagon. For 6, it's called a hexagon. For 7, it's called a heptagon. For 8, an octagon. For 9, a nonagon. For 10, a decagon. For 12, a dodecagon. And for n, that just represents the number of sides, right? So if we have a figure that's 20, that's 13, that's 17, we're just going to call it a 20gon, a 13gon, a 17gon, or in this case, an n-gon. So if I'm giving you an example for that, if we have like a 13-sided figure, we're just going to call it a 13gon. I know I was speaking quickly, so take a few seconds to catch up. And remember, if you need to pause this at any time, pause it, rewind, go back, go forward, please do. Use these notes to your benefit. Okay, we are going to continue on and talk about a convex polygon. A lot of these definitions are pretty crucial. A convex polygon is typically the type of polygon that we'll be using in these polygons. A convex polygon is just a polygon or a figure with all interior angles less than 180 degrees. When we're drawing this example of a convex polygon, we are going to make sure that all of these angles are less than 180 degrees or less than a straight line, which will probably be easiest for you to do as opposed to our concave polygon. So I'm just going to draw some lines and make sure they're connected. So we have 1, 2, 3, 4, 5-sided figure, and as we know from when we're naming these, a 5-sided polygon is called a pentagon. A concave polygon. A concave polygon is just a polygon with one or more interior angles greater than 180 degrees. Or greater than a straight line. So when I'm drawing this concave polygon, I'm first going to start by drawing an acute angle. Okay, that's going to be the part of the polygon that's concave, that's going into that actual figure. Then I'm just going to draw some lines, some angles connecting that acute angle from end to end. So here, when I'm double checking to make sure I've created a concave polygon, this angle here, that angle is greater than a straight line, right? So I have created a concave polygon or a dip in that polygon. We have a couple other types of polygons that we still need to learn about. This next one is called an equilateral polygon. An equilateral polygon is a polygon that has all equal sides, equilateral. So it is a polygon with all sides congruent or equal. I'm sure you guys can guess what an equiangular polygon is, right? Equal, equi, and then angular. We're talking about the angles. So that type of polygon is a polygon with all angles congruent or equal. Equiangular. A regular polygon deals with our equilateral and equiangular. A regular polygon is a polygon with all sides and angles congruent. So here, let's draw an example of a regular polygon. So dissecting this meaning, right? Regular means equal angles and sides. So congruent angles and sides. Quadrilateral, we know that we need to have 4 sides. So in this case, I'm going to just sketch out my 4 congruent sides. I have 1, I have 2, I have 3, and I have 4. When we have those congruent sides, we mark them with tick marks. So I have my 4 congruent sides. Do I have my 4 congruent angles? 1, 2, 3, 4. And we'll be learning a little bit later on why each of these angles will be right angles. But for right now, we know that all 4 angles will also be congruent. When we're drawing an example of a concave heptagon, let's figure out what this concave means. Concave just means one angle is greater than 180 degrees. Heptagon, right? Heptagon means 7 sides. So I'm going to first create my concave part of the polygon, right? I'm going to create that acute angle, technically acute angle. And then I want 7 sides. I want 5 more sides. Right now I have 1 and 2, which create that angle. So I'm going to go 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Awesome. So right now I have a concave heptagon. You may need to try it a few times in order to create that concave heptagon or concave pentagon. Make sure you do create or use a pencil so you can erase some sides, extend some sides, so on and so forth. Okay, let's continue on to some interior angle type of problems. So here are types of polygons that we just talked about when we're classifying them. We are now just going to talk about the sum of the interior angles. In the past, we've talked about our triangle, right? We know that all angles, 1, 2, 3, 3 angles have to add to 180 degrees. Now, if we're talking about a quadrilateral, which we also know now, which has 4 sides, we can figure out how many degrees are in the inside of this quadrilateral by creating some triangles. So I'm going to actually create a diagonal which goes from one side of the polygon to the other. So I'm going to create a diagonal. And you see here that we have 1 triangle and then 2 triangles. So we have 2 triangles within this quadrilateral. Okay, cool. What does that mean? What it means is we will have 2 times 180 degrees of that measure. So of all of the interior angles within this quadrilateral, we will have a measure of 360 degrees. That will help us out later when we're solving for measures within the quadrilateral. Okay, let's give a pentagon a try. So pentagon, we know already that there are 5 sides. I'm going to create some diagonals to figure out the number of triangles within this figure. So here is one diagonal, right, creating a triangle on the top. Here's 2 diagonals. So right now we have 3 complete triangles within this pentagon. We're going to take 3 and multiply it by 180 degrees. When we multiply 3 and 180 degrees, we will get 540 degrees. I want you guys to try the same thing for a hexagon. If you're not comfortable, then you can just really listen to the rest of the video. If you're comfortable, go ahead and pause it and see if you can figure out the number or the measure of the interior angles of a hexagon, which is a 6-sided figure. Okay, so what I found for a hexagon was, yes, we have 6 sides. There are 4 triangles that are created within this shape. We do 4 times 180. We know the sum of those interior angles will be 720. For these types of problems, we have a specific formula. Based on n, the number of sides, we will always have n minus 2 triangles. Okay, the reason why that's helpful is because we will plug that into our formula. We can always do n minus 2 times 180 degrees to figure out the sum of the measures of the interior angles. So that will actually go in our formula box. N minus 2 times 180 degrees. That is one formula that you'll be given on the quiz and test. To find the measure of one interior angle of a regular polygon, you'll do n minus 2 times 180 and divide it by the number of sides. Because we know that if we have the same number of sides, or if we have a number of sides, we'll have that same number of angles. So it's the measure of one interior angle. The top one is the sum of the interior angles. So this is all, and this is 1. Okay, let's give these a shot. So for number 1, we have quadrilateral PQRS. How many angles do we need, or how many measures of an angle do we need within this quadrilateral? If we go to the top, right, we can use our formula to figure out, right, we have 4 sides within this figure. We subtract 2 and multiply it by 180 degrees. When we simplify that, we will know that all of these angles will add to 360. We do not know all of the angle measures, but we can find them out. We know that 80 plus 70 plus 2x plus x all add to 360 degrees. So let's set up that equation and solve. We combine all our like terms on the same side of the equal sign. So we get 150 degrees plus 3x is equal to 360. We can then subtract 150 on both sides. When we do that, we get 3x is equal to 210. Divide both sides by 3. And we get x is equal to 70. Okay, when we're finding the measures of each of these angles, we then plug them in. So Q has a measure of 70 degrees, R has a measure of 140 degrees. 2 times 70, which is 140. Okay, I'd like you to try number 2 and number 3. First, identify the polygon, and then set up an equation to solve. check your notes, the key, on Canvas.